Good day, folks. Welcome to my YouTube channel. Today we're looking at the national paper, the 2023 November. It's electrolytic cell. An electrolytic cell is a setup to purify a piece of copper that contains silver and zinc impurities. And it's a simplified diagram of the cell shown below. Electrode R is an impure copper. So we're told this one is an impure copper, and now we know the impure is the positive, which is the anode, right? And then that simply means this side is going to be the cathode where the reduction takes place, right? Now, and if you see here, this impure is purified to that one. So that means the copper ions are going to fall off that one. Cu2 plus, Cu2 plus, Cu2 plus are going to fall off there. One of the impurity, which is silver, it fell on the bottom of the electrolytic tank, right? And then the copper is going to be reduced so there's a reduction there and there's an oxidation there, right? So 9.1, it says define the term electrolysis. You define it according to exam guideline, guys. It's a chemical process in which the electrical energy is converted into chemical. Very important. 9.2, it says write down the reaction that takes place in electrode Q. Electrode Q, it's where the reduction occurs. It's a Cu2 plus is reduced to Cu in a solid state. Now it says in which direction do the electrons flow externally, which is they flow from R to Q. They flow from R to Q, from an anode to cathode there. Now 9.4, it says calculate the current needed to form 16 gram, that's the mass of copper when the cell operates for 5 hours. That's the time. So it's 5 hours, you times by 62 minutes and times by another 62 seconds, right? This question, guys, basically it says let us calculate the current that is needed when the mass that is going to be deposited there it's 16 gram, right? We want that. So in 9.4, what we will have to do there, we'll have to change the mass of copper into number of moles. So the mass is 16, we divide by what is the molar mass of copper? It's 63.5. The answer is going to be 0.25 mole and then step number 2, we change the number of moles into the number of moles in terms of electrons. So it's a number of mole electron for copper is going to be the number of mole of copper times the Cu, guys, it has 2 electrons. We're going to times by those 2 electrons there. So it's 0.25 times by 2. The 0.25 we times by 2, it's going to be 0.5, right? 0.5 mole electron. And then step number 2, we change the mole electron into electrons, right? Which is, we take this value, we substitute it there. It's 0.5 is equal to, and over that we times by Avogadro. It's 23. So when you punch that in the calculator, 3.6 0.033 700 times 10 to the power 23 electrons. And then we're going to change those electrons by using the quantization. Number of electrons is equal to Q over QE, which is, it's going to be, we take this number of electrons, it's 3,033 700 times 10 to the power 23, which is the answer on my calculator. We want Q, we times by the elementary charge, which is we times by 1.6 times 10 to the power negative 19. The answer, the Q is 4853 539,216 coulombs. And then from that we'll have I is equal to Q over change in T, which is, it's going to be 485939,216 divided by 5 times 60 times 60. So I will say answer is equal to, answer divided by 5 times 60 times times by another 60. Yeah, the charge is 2.2 comma the electron, the current, punching that in the calculator is 2.69 amperes. That's the current that was needed there, right? It says during the electrolysis only copper and zinc are oxidized. Give reason why silver is not oxidized. If you look in the table, guys, if you look in the table, this is 9.5. I'm going to answer here. If you look in the table, Ag there, Ag is a weaker reducing agent, because Ag, it's at the bottom of the table. 4b, it's a weaker reducing agent than Zn and copper, right? And will not oxidize. The Ag is a weaker reducing agent than zinc and copper and will not oxidize. That's the answer there. I hope it makes sense.